At this time, I'd like to introduce our presenter, Andy Kester, Director of Marketing for System Sensor. Andy, take it away.
All right, thank you much, David. I think we have a real exciting topic here that we're going to be talking about with mission-critical facilities and what kind of smoke detection issues can arise to meet those needs. So some of the topics that we'll talk about are just that, the opportunity within the mission-critical market, the mission-critical mindset, which is different from the mindset that maybe we traditionally are experienced with smoke detection. We'll go in pretty good detail through some of the applicable codes and standards associated with mission-critical facilities. And then throughout that code and standard section, we're also going to talk about FAAST, our latest launch into the aspiration market, and how FAAST has has the ability to meet and exceed these code requirements that can be sometimes challenging. And then finally, some takeaways, just kind of summarize what we've discussed. So if we look at the aspiration market in general in the U.S., you'll notice that the mission-critical segment is by far the largest segment. We roughly estimate the market as being about a $40 million market in the States, and 65% of that, again, is mission-critical, with the balance of the other 35 or so% rounding it out between large open spaces, access denied, so that's your prisons and other type of security-based locations, and then environmental extremes, so maybe real broad temperature ranges, cold food storage, and some of those types of applications. So obviously a big opportunity within aspiration with mission-critical facilities. So just to kick things off, not to insult anyone's intelligence, but what exactly is mission-critical? Well, it's defined as an activity, device, service, or system whose failure or disruption will result in the failure of business operations. So we list some applications here, everything from telecommunication facilities, computer rooms, data centers, financial institutions. However, you look at it also, we recently did a case study on a museum, and they viewed the smoke detection system that was in that facility as mission critical because of the fact that if there was some sort of fire, A, they'd have to shut down and close the doors, B, it could put a significant risk to their assets. So even though we always seem to talk about that high-tech side of things when we're talking mission-critical, it can by far branch into many different applications. So we look at the data center market growth, which obviously data centers are a huge chunk of the mission-critical facilities. You look at it within the United States, you see some pretty good growth if you compare it to some of the other channels, if you will. Roughly, we're sitting in somewhere around $12 billion of annual construction with data centers. Obviously, globally, that expansion and growth is far more significant. But on both sides, globally and in the U.S., offers a really nice growth projection. If we look at the U.S. data centers and kind of where they stack up, you'll notice that pretty much they're across the entire country. There are only a few pockets that I would say wouldn't necessarily, data centers wouldn't be applicable for, or there aren't any today. And you look at, you think about the growth trajectory, the amount of data centers. You look at things that are going on today with, Facebook and other types of programs like that that are putting a huge burden on the existing data center infrastructure, basically to keep up and keep that data moving. So mission-critical mindset, I talked about the fact that on the onset that the whole mindset and thought process is very different from maybe what we're used to dealing with smoke detection, where it's meet the minimum of the code and that's all many people are looking for. Conversely, with mission-critical facilities, their focus is really on efficiencies, uptime, proactive and preventative maintenance. Basically, anything they can do to keep things running without any kind of interruption or any kind of hiccups. We're going to continue to dabble in aspiration where it seems fit, and they view aspiration and smoke detection in general as really an active part of their building management system. Rather than having a system where it alarms, you evacuate, they really want to use it as a means of, again, managing that system, mitigating risk, identifying the risks and mitigating them before they can turn into a catastrophic event. And also, when you look at most of these kind of facilities, the equipment within these facilities and the problems that can arise and the cost ramifications that can arise if these facilities need to be shut down, the fire system cost, even if it's a real high-end system, is very, very low from a relative standpoint to the equipment in the facilities. Excuse me. So taking that mindset a step further, what are some of the drivers when we're starting to talk about these facilities? What do they find important? What are they trying to really accomplish? Well, obviously the number one thing is preventing data and revenue loss from downtime. Again, protecting the equipment, not just from not just that core life safety perspective, but really protecting the equipment from smoke, fire, water damage that basically would make that equipment a complete loss, unusable. Providing the earliest detection possible, again, being able to mitigate that risk at an early stage. Having the ability to identify different stages of a fire so that they know whether or not they can handle it locally or whether or not they need to pull in exterior resources. Also, these data centers and other mission-critical kind of facilities, they have a very diverse size and scope. You can have facilities that are basically, very, very small in stature, very modular, to facilities that you could be talking, million square feet or more in order to that you have to provide protection for. And again, they're really leaning more and more day after day towards having more of an integrated system with the fire, with this traditional fire system. Okay. So with that note, what other kind of trends are happening in these facilities? Definitely a convergence between the IT data centers and the communication facilities. You think about it, in the past, telecommunications were one thing, and data transfer was another thing. You look at today, the fact of how many people have cell phones that aren't used for emergency, but for day-to-day, everyday need and use. The amount of text messaging going on, emailing going on from smartphones and those type of things. It's just unnatural that these two entities are going to continue to merge, and they're looking for other ways to protect those assets and approaches to, again, mitigate risks and do a much better job of evaluating trade-offs. Historically, these have been very, very prescriptive in base nature for the codes and standards, but because of the very diverseness of these kind of facilities, it's becoming much more acceptable to have performance-based approaches as long as that the risk analysis is done properly. And then again, as I kind of alluded to earlier, there's this ever-increasing critical nature of the IT. Back in the days when people were using cell phones and email as a nicety or a convenience, it's much more a critical nature. You think about a server going down today and, at your own facility or business where you can't send email, it becomes a very, very critical nature that it can drastically hamper your ability to conduct your business. So, many of you, no matter what kind of entity you are, whether you're an engineer, whether you're a engineered systems distributor, or something in between, who should be engaged when you're talking to these mission-critical facilities? Well, the HSC manager, facility manager is always a logical starting point. Also to note in these facilities, per NFPA 76, the Standard for Protection of Telecommunication Facilities, they require that a fire safety manager be assigned to each one of their facilities. So that's another great source. And then finally, one area that maybe you don't think about is the IT manager, who again could cross over and be that facility manager. But why would you want to talk about the IT or talk to the IT manager? Excuse me. Today, again, because of the growth and the expansion of IT, currently, if you look at budgets across many companies and facilities, the IT department typically has a greater willingness to pay to protect their assets. They also, if you look today, most often, they have a more availability of budget compared to the fire department areas or that HSC safety department in order to provide the best protection possible. And they also seem to have a better understanding of the things that we're doing today to integrate the fire system into the building better, whether that be TCP/IP or some other communication protocol. And they value that integrated system, whereas maybe in the past you might have talked to people and they wanted to keep that fire system separate from the rest of the building system. The IT people seem to really kind of get it, that there's value in integrating those two systems together. So with that, we'll turn it over to David for the first poll question.
All right, Andy, thank you. Thank you for that. Okay, this is the first opportunity to use the polling feature on our webinar. What I'd like you to do is click the response that you think is the correct one for this following question. This is more of a quiz question for you, but we want to just gauge the knowledge in the audience, so please answer, if you would, in the next few moments. So the question is, which of the following standards require the use of aspiration smoke detection? Is it the NFPA 72, the Fire Alarm and Signaling Code, NFPA 75, which is the standard for the protection of information technology, 76, which is the standard for fire protection of telecom, all of the above, or none of the above? So if you would, we'd appreciate that a very large percentage of you would vote. So please take an opportunity at this point, and we'll just pause the program for a second to allow you to do that. Go ahead and vote. We'd like to get to about 80%. We're about 60% now, so if you would, please go ahead and click the response that you think is appropriate. And of course, we'll share the answer with you here following. And we'll also always share all of the poll question responses, so you can see how you and your colleagues have voted on various things. All right, Andy, we're at 81% voted, so thank you. The 19%, please step up the next time, and I will share these results with you. Andy, it looks like most folks are saying 40% are saying all of the above, 33% are saying none of the above, and the highest specific NFPA code that's mentioned is NFPA 76. That's standard for fire protection of telecom facilities at 16%. So I know you're gonna set them straight here. So I'll go ahead and take those results down, and we'll get back to you, Andy.
All right, great. Again, that poll question was more of a precursor to just kind of see where everyone stands. The answer to that question actually is none of the above. And we're going to go through each one of those standards in a little more detail. It's a kind of a misnomer that a lot of people think, especially NFPA 76, calls out the requirement for aspiration. The fact of the matter is none of the three specific call out the use of aspiration, but rather if aspiration is used, here's the standard, here are the requirements that you have to meet. So that's kind of the caveat. It wasn't meant to be a trick question by any means, but I think, again, as we go through the standards in a little more detail here, I think it'll hopefully educate everybody a little bit tighter on these standards and how it relates to aspiration smoke detection. The first code we're not going to really spend a whole lot of time on is NFPA 72, the National Fire Alarm and Signaling Code. This code, obviously I think everyone in the fire industry is fairly familiar with it. Basically, the only thing that kind of crosses over into that aspiration area, as well as mission critical, is where it advises smoke detection spacing in high air movement areas to be reduced. So you think about these mission critical facilities that maybe have hot aisles and cold aisles, high rates of air change in telecommunication, IT kind of areas. NFPA 72 is just saying, if you have these kind of high rates of air change, you do need to reduce the coverage or reduce the spacing of a standard smoke detector. The second code, again, we're going to go into these in more detail, is NFPA 75. This is the standard for protection of information technology equipment. This code, in just general terms, offers prescriptive and performance-based approaches. It also requires automatic detection with some sort of early warning of fire. Now, again, just because it calls out for early warning, a lot of people jump to the conclusion that aspiration is required. It's a viable solution for early warning, but recognize that just a standard photoelectric smoke detector, the sheer nature of a smoke detector is supposed to be for early warning, basically prior to a major event that allows people to evacuate. And then finally, the third one that we'll talk about is NFPA 76, the Standard for Protection of Telecommunication Facilities. And this is the one I always talk about that starts to get a little bit more detailed as to that there's 3 levels of protection, and I'm not going to really go into those too much now. We'll get into it later. And then also the coverage area as well as transport time if aspiration detection is used. And again, for all these standards, ultimately the AHJ dictates fire protection requirements. It's kind of our standard saying, but it does hold true in every jurisdiction. So if we go into NFPA 75 a little deeper, as I alluded on the previous slide, it does call out for automatic detection equipment shall be installed to provide early warning of fire. The equipment shall be used and listed, shall be listed smoke detection type, and shall be installed and maintained in accordance with NFPA 72. So it does ratchet back up to NFPA 72. With the automatic detection, it does call out that 3 different areas where detection should be used. A, at the ceiling, throughout that information technology equipment area. Below a raised floor, in any area that would be containing cables or transmission cables. And then 3, above the ceiling and below the raised floor, where these spaces are used to recirculate air to other parts of the building. So again, if air comes into that information technology equipment area, and then it's going to be filtered in through other parts of the building before returning to the HVAC system, you would need to be above the suspended ceiling and then also below the raised floor. Now, there are some discussions currently going on with NFPA 75, some proposed changes, but I'm not going to speculate on those because they're still out for comment. So what does FAAST have that can help meet that need of potentially having to have detection below the floor and above the ceiling? Well, FAAST actually has an internal manifold, and what that does is it enables pipe connections from the top of the unit or the bottom of the unit. So it simplifies underfloor pipe networks. Many of the competitive products require that the unit be installed inverted or upside down if you need to bring piping in from the floor or from the bottom of the unit. Okay? What this does also is it allows you to use one product for above the ceiling, below the ceiling, or below floor applications. And ideally, if you don't have to route the pipe in such a convoluted path to either reach the top if you're coming from the floor, you can bring it in right from the bottom. That does save time and labor. And also, because we don't have to invert the unit, it does also provide a more user-friendly display because that display is not maybe turned at a 90 degrees or upside down. So it does help the customer in that regard as well, just from a user interface. So shifting from NFPA 75 into excuse me, NFPA 76, the first area that we're going to talk about is Section 8.4, which is alarm processing. And what it does call out is that fire alarm supervisory and trouble signals shall be enunciated at a constantly attended location. More specifically, the use of very early warning fire detection, and we'll go into each one of these types of detection levels in forthcoming sections, need to have an alert or a pre-alarm condition. And again, it doesn't necessarily have to be aspiration, but more commonly than not, it is. So need to have an alert level that provides a pre-alarm condition. And this needs to be initiated with local personnel, authorized personnel before the fire department's notified. So that's, it's more that pre-alarm that they're using to, again, actively manage their system. In addition, fire alarm signals, like in many other applications, need to take precedence over all preceding alarm signals or any other signals. I recognize that with emergency communication systems and mass notification systems, that's slowly migrating, but that has not reached back into NFPA 75 and 76 yet at this time. So the fire alarm signals still take precedence. And designated telecommunication personnel need to be dispatched to the site immediately upon receipt of an alarm. Again, both in that pre-alarm and alarm state. So how can we notify people as efficiently as possible? Well, with FAAST, we do have several things that provide a more integrated communication advantage. The first of which is email notifications from the device. are sent to identify alarm, fault, and isolate conditions. And when we say alarm, that does include the alert or pre-alarm level. An onboard Ethernet or TCP/IP basically provides that local networking capability and monitoring from just about anywhere around the world. In addition, if you set up the network with a SMTP mail server, that does enable the email notifications. So a real nice way to be proactive rather than having to rely on that local personnel that's monitoring it 24/7. The FAAST device does give you some other opportunities to notify the corresponding personnel as needed in order to identify risk and mitigate those risks as much as possible. And again, taking it a step further, in order to have that remote monitoring, the PipeIQ software does allow you to configure design pipe network and also monitor if you are monitoring locally, not at the device, but maybe at a command station or something within the facility. So moving ahead, again, continuing with NFPA 76. Now we're in 8.422. This is where we're talking about supervisory signals. Supervisory signals shall be given priority over all other general building maintenance alarm signals. So we already talked about fire takes the priority. Supervisory also we want to take priority over any kind of general building alarm signals. Excuse me, the supervisory signals shall include and are not limited to, and this is a truncated list, not the complete list that shows up in NFPA 76, but again, supervisory signal would be viewed as that alert or pre-alarm signal, especially with a very early warning fire detection system. And then again, it does allude to fire alarm initiating devices that are more specifically designed for supervisory signals, again, such as a duct smoke detector. Duct smoke detectors are more so there or are supposed to be there for supervisory concerns rather than evacuation or alarm events. However, again, it depends on the code and the jurisdiction. Oftentimes, duct smoke detectors can be used as that evacuation device as well. And then in 8.4227, the alert pre-alarm signal from this very early warning fire detection system shall be distinguishable from all other fire alarm, supervisory, and trouble signals. So what does FAAST have that can help with these pre-alarms and various type of action plans that you need to put into place depending if it's a pre-alarm or a real alarm? Basically, FAAST offers 5 different programmable alarm levels. And again, if you look at the chart, it's a little hard to see, but that lowest alarm level is the alert level or the pre-alarm level. In addition to that level, there's 4 additional levels to set multiple action plans in place. Those relays associated with the alarms can be set for latching or non-latching. So for instance, for an alert level, maybe you want that to be a non-latching relay because it's just for supervisory. In addition, you can add 0 to 60-second delays on each one of those alarm levels. And we'll talk about why you're able to do that with FAAST versus maybe some other products. And then finally, we haven't really got into false alarm immunity and sensitivities yet, but FAAST does also offer an acclimate mode like many of our other spot type detectors that automatically adjust the sensitivity based on your environmental condition. And as I kind of talked about at the onset, these mission critical data center kind of facilities are evolving drastically when it comes to both their HVAC systems, how they're cooling the equipment, and again, that environment isn't necessarily static from hour to hour, day to day. It's changing, ebbing and flowing, and the acclimate mode is greatly suited for those type of applications. So with that, we'll turn it over to David for the next poll question.
All right, Andy, thank you. The next poll question is more of a business question. So what percentage of your business do you consider is mission critical facilities? So let me ask that again using correct English. What % of your business do you consider is with mission critical facilities? So you've dialed into a mission critical smoke detection webinar. So if you could indicate less than 10%, somewhere in that middle 11 to 25 or 26 to 50, or maybe a bulk of your business is focused on mission critical. As Andy talked about, it's something that is obviously across the country and in a lot of different types of venues. So please go ahead, take an opportunity to vote. We'd love to see and engage the attendees that we do have online with us. We do have a large number here, so we're hoping it's somewhat representative. So go ahead and vote. We're at 75%, so please, if you haven't voted yet, go ahead and click the response that's applicable to your business, and then we'll promise to share those with everyone. And just a reminder, I said in my opening introduction that we will take questions in the order received. If you do have a question, go ahead and use the chat box. And following our third poll question, and also at the end of the webinar, time permitting, we'll take those in the order received. Okay, great. We're over 80% response, so thank you again. Once again, Andy, 19% held out voting here. I'm not sure why, but it's a consistent number. Let me go ahead and close the polls, and I'll share those results back with you. Andy, it looks like less than 10% is the largest category at 54% of our attendees today, and then 25% are indicating it's 11 to 25%. But, you know, interestingly, 7% are indicating that it's more than 50% of their business. So some people are very much engaged in mission critical. So Andy, I'll take those poll questions down, and we'll go back to you.
All right, great. Thank you. Well, hopefully, you know, what we kind of talked about as far as the opportunity goes at the onset of the webinar, hopefully those of you that have not been dealing with mission critical arena or markets, hopefully will find it compelling enough to dive into it. And I think throughout the rest of the webinar, hopefully we'll help educate you so that you're more comfortable with doing so. So we're going to continue on here with NFPA 76 and moving into section 8.4.2.3, which is with related to trouble signals. And for this one, I'm just going to flat out read the standard here. It says where monitoring systems provide the supervisory station with detailed trouble information that allows determination of the degree of system impairment, response shall be permitted to be delayed until the next working day, where it is determined that the trouble does not affect the ability to detect and report a fire condition. So that's a lot of text, but, you know, I think we all understand what we're saying here is that, you know, for a trouble condition, rather than have to race out and address it at that immediate instance, as long as the device or the system gives good discrete information as to what is going on with the system, if it's not jeopardizing its ability to detect smoke or fire and report the fire condition, it can be delayed until that next working day. So one great example with FAAST that we're able to do is related with the actually replaceable 30 micron filter. Once that filter starts getting dirty to the point where it needs to be replaced, a minor trouble is sent 72 hours before that filter maintenance is truly required. So a great pre-alarm. It gives you very discrete information with that that tells you that it's due to a filter. It tells you it's a minor fault or minor trouble. So you know that you have those 72 hours. After those 72 hours, if that situation hasn't been rectified, the filter hasn't been cleaned or replaced, a major trouble would occur. And what this allows you to do is it you know, basically provides you that type of discrete information you need in order to agree with the standard that we just read as far as trouble conditions. In addition, our filters actually have a much longer life than a lot of the competitive products, which rate them at about 2 years. We're rating our replaceable filter at about 4 years. The main reason for that is the upper left image here is a particle separator, which is upstream of the filter, and basically takes any of those large particles that wouldn't be associated with any kind of smoke or incipient stage of a fire, and basically filter those out without even going through the filter and exhaust it directly out of the unit. So what it does is it takes a lot of the burden off the filter, and it allows you to have a longer filter life. We'll talk about the last bullet item a little bit further later, but we also have electronic nuisance rejection through the algorithms we're using in the sensor chamber. In addition to this is just one example of one of the trouble conditions that you could get from a FAAST device. FAAST actually provides over 10 discrete fault indications. The nice thing about it, again, some of those are major in nature that need to be addressed immediately. and could compromise the device. The majority of those are more of the minor area that, again, based on the standards and the way that standard was written for trouble conditions, could be delayed till that next working day. So, you know, the old adage that you get that notification at 3 a.m. on a Saturday, it allows you to give you, at least 24 hours in order to address it. Getting a little more detailed into or deep into the NFPA 76, Section 8.5, which specifically starts talking about fire detection. In Section 1.2, defines the levels of protection, and this is this is where many people think of when we're talking about NFPA 76. Describes the highest level of very early warning fire protection. The next stage down is early warning fire detection, or EWFD, and then also standard detection. Again, with very early warning fire detection, a lot of people jump to the conclusion that aspiration is the only thing that can meet that. Quite honestly, some other laser-based spot detectors and other products can meet that. But again, most commonly, aspiration is used to meet that need. And then finally, early warning or very early warning fire detection smoke systems shall use sensors or ports with spacing that is less than normally required. So much like NFPA talks about with high velocity areas, you need to reduce the spacing. In NFPA 76, it also talks about reducing that spacing. And again, remember that whether you're using a spot type detector or sampling points, either way that's basically viewed as a point of detection. So that spacing needs to be reduced to meet early warning and very early warning. And we'll go into more detail on how that's accomplished. Okay, specifically for very early warning, basically says that every type of sensor or port installed into the area must be limited to a maximum coverage of 200 square feet. So if we look at standard detection, as laid out with NFPA 72, that standard sampling point or sampling port is good for 900 square feet of coverage. To meet very early warning, that's ratcheted all the way down to 200 square feet. Also, if we think about a data center where, as it was talked about earlier, where you might have two different levels of detection. So maybe you have a certain level of detection at the ceiling, but then you also have a certain level of detection at a lower level. Each one of those independently can be at 400 square foot of coverage, as long as when you combine the two, you do meet that 200 square feet for very early warning. Okay. Additionally, in 8.5.3.1.2.3, it calls out that sensor ports shall be installed to monitor return airs from the space. So here again, if that air is leaving, which, in order to maintain the air changes and keep the equipment cool, a lot of air changes have to occur typically. It does require that you monitor the return airspace from that space. And in A, it talks about where standalone packaged HVAC units are installed. Again, you need ports shall be installed where the return air is brought back to the unit. Where those sensors or ports shall be installed such that each covers no more than 4 square foot. Now again, aspiration is a great method and tool for smoke detection in these facilities. You can put the sampling pipes directly across the front of the return grill or within the ductwork. But I do want to point out also that high sensitivity duct smoke detectors, which System Sensor does offer, is also a great solution. Depending on your size of your return air duct or grill, you may need to use 2 or 3 duct smoke detectors in order to meet that 4 square foot coverage area. But it also does provide an alternative to aspiration. Okay, continuing on, and again getting into more of the meat when it comes to very early warning fire detection. In Section 2.5, it talks about both the alert, or that pre-alarm level, as well as the alarm, or the lowest alarm level. And it talks about the air sampling, whether using air sampling or spot detectors, needs to be at 0.2% per foot obscuration. And the one thing to note here is if you're using air sampling, that's at the sampling point. So the sensitivity at the device will have to be set significantly greater due to dilution. And also, you don't know that, let's say you have an air sampling system that maybe has 10 holes. Only one of the holes might be detecting the incipient stage of a fire. So that one sample gets diluted by the 9 other samples when it gets back to the device. So the device has to be set significantly more sensitive to meet that 0.2% per foot obscuration. And then similarly with an alarm condition, again, whether it's air sampling or spot detectors, needs to be at 1% per foot obscuration. And then finally, if you're using aspiration systems, it calls out that the maximum transport time cannot exceed 60 seconds. So again, with air aspiration systems, there is a transport time associated with between the time that the sampling point smoke is introduced into that point until the device detects that condition. And for very early warning, it has to be 60 seconds or less to meet the standard. Continuing on with early warning, just the way the standard's laid out, it starts with very early warning and then backs off to early warning. Much like with very early warning where it said that sampling point coverage could be at 200, for very early warning it's a little softer coverage, and that can be limited to 400 square feet. The minimum alarm level, instead of being 1% per foot with very early warning, can go up to 1.5% per foot. And again, that maximum transport time for early warning is extended up to 90 seconds. So then again, to recap, for very early warning, 60 seconds transport time. For early warning, we're at 90 seconds. And then for standard detection, 120 seconds. Again, this is if you're using aspiration to meet the NFPA 76 requirement. So what does FAAST have to meet those needs? Well, for one thing, it has the broadest sensitivity capabilities of any aspiration product on the market, from 0.0046 to 6.25. You might say, well, why does it have to be so low if all I have to get down to is 0.2? Well, remember, with air aspiration, the device has to be set significantly lower than the sampling point in order to have that effective sensitivity at the point. FAAST is also UL and FM listed for early warning as well as very early warning fire detection. So it has passed these wire burn and other tests that are laid out in the standard in order to carry this listing. And then what we do quite a bit differently from a lot of other aspiration systems is instead of having a single source looking for the incipient stage of a fire, we actually have 2 sources. So we're using a blue LED that covers the widest range of fires, especially in the incipient stage. And then we're using an infrared laser basically not to detect smoke but to detect dust. And with the advanced algorithms between these 2 sources, we're able to do a much better job of determining whether or not we have a smoke condition or a combustion condition or a dust-based condition. Basically what this does is just provides more accurate smoke detection in these mission-critical facilities. Continuing on the same idea of the dual sources, FAAST also provides superior false alarm immunity. And how we're able to do that is, again, with those 2 sources. I like to equate it to having those 2 sources as kind of having a 3D look at a particle. And with that 3D look, we're analyzing the particle for size, not just a 2D size, but a 3D size, color and reflection of that particle, and the signature of the particle. Smoke particles and dust particles have a drastically different signature, and with this 2-source capability and the algorithms that are interpreting that data coming in from the 2 sources, does provide a much improved false alarm immunity with the FAAST device. And then again, we take oversampling of those particles. So even once we've gone through all that analysis, we look at multiple samples, we delay it a little bit just to make sure we actually have a fire condition. And when I say delay, we're talking milliseconds type timing. So with that, we'll turn over to David for the final poll question.
All right, thank you, Eddie. And we do have a couple questions in queue here, so following this poll question, we will answer a couple. We'll allow Andy to finish his presentation and then handle the final questions at the end. We're right on time. So the next poll question actually has to do with the FAAST aspiration system that you've seen. Since its launch last August, we've sold hundreds of units, and we wonder if you have been one of the people that may have specified, quoted, or installed FAAST. Trying to gauge who's online with us here. So have you specified, quoted, or installed a FAAST aspiration system to date? Simple yes, no. And perhaps you're in a business, maybe you're an AHJ dialing in, or a researcher or something like that, and you don't specify quote or install, go ahead and feel free to click that button. But if you could, go ahead and vote for us. Lots of votes flowing in now, and then we'll get to some responses here. So good. We just crossed that 80% threshold. We're at 81. That's been our limit the last couple times. Oh, we got to 82. So thank you. Someone else stepped up. I'm going to go ahead and close the poll. As we pretty much expected, yes is 14%. So thank you very much for being a customer or for quoting FAAST. No is 74%. So thank you for checking us out today. And then another 12% are in that other category. So we appreciate you attending today. Andy, the first couple of questions here has to do with the first question actually has to do with hole spacing. How do you determine hole spacing on an aspiration system in applications where there's high ceilings, like an atrium? And then there's another question here on an airport hangar, similar type question. How do you determine hole spacing for aspiration systems?
Okay, well, again, it basically comes down to your coverage, and there'll be a maximum coverage point. Again, you know, if we're talking about a mission critical facility, I realize the question was airport hangar, but with a mission critical facility, you know that you have to have a maximum of 200 square foot per coverage. In some of the other applications that were mentioned, again, the 900 square foot would be suitable to meet standard code. However, you know, in order to improve the performance of the product and to give some redundancy to the system, obviously sampling points can be put in at closer intervals. One such area you might say is, okay, you're monitoring a return air grill in a certain facility or something like that. It would not be inconceivable that you could have, you know, 4 to 10 holes in a very short run of pipe within the ductwork, if you will, much like you would with a duct smoke detector. Again, because you're trying to identify just that very specific ideal location rather than trying to cover a vast area.
Mm-hmm. Okay.
So the PipeIQ software that does come with FAAST does a good job of helping you lay out those scenarios.
Okay. Next question here, can you discuss the FAAST communication capabilities and are there network communication capabilities linked to FAAST?
Yeah, again, the product is a conventional product. So to tie back to an alarm plan or something along those lines, today you would have to use a monitor module of some kind, addressable monitor module of some kind to bring that back to the panel to integrate it into the standard fire system. As far as communication, as we talked about, to communicate those alarm conditions, you do have the capabilities of setting up the email. The only caveat is the unit would have to be connected to a TCP/IP network connection, which you look at most facilities today, that infrastructure is already there, so it's just a matter of tapping into it, giving the FAAST device a static IP address so they can be identified. And then as long as that network has an SMTP mail server, the FAAST device has the capability of sending those email notifications out to the device. So it's kind of twofold. One is the notification, if you want to have the email capability. The other side of it is how to tie back into an existing fire system through the modules.
All right. Just looking at the time, Andy, why don't we complete your presentation and then we'll handle the rest of the questions at the close. Okay,
great. So we spent quite a bit of time talking about both the mission critical as well as some of the codes and standards, and really how FAAST can help you meet those codes. I do want to note that System Sensor doesn't just have aspiration, but it has a full complement of detection and notification appliances. The balance of devices outside the aspiration do help meet the other needs of the facility's code requirements. And it's not inconceivable that you would have aspiration in certain parts of even these mission-critical facilities, and then maybe even standard detection or other types of high-sensitivity spot detectors in other areas. The ability to tie that full complement of products into fire panels for that full integrated solution is definitely available through System Sensor's offering. And what it does, and what we've really heard from a lot of customers, especially in these mission-critical facilities, is it really relieves a lot of the concerns of multi-brand products and the concern over will these products all talk together and be compatible together. And with FAAST and the rest of the System Sensor offering, that's it is the case, I should say. So in addition, more specifically, some of the other products that are very, very conducive to the mission-critical type facilities that need this early warning or very early warning is our Pinnacle laser-based and intelligent high-sensitivity spot detector. Again, that does give you that point ID. So if you have a certain area or maybe a certain piece of equipment, maybe you don't want to use aspiration there, or maybe you want to use aspiration in the general area, but then directly on that piece of equipment or directly above that piece of equipment, if it's super critical, you can have a addressable spot laser-based detector that gives you that identity of giving you that point ID to know exactly, rather than just a general zone, but exactly where that condition is, and go and mitigate that risk. Likewise, we do have our GNR HS, or our duct smoke detector, with that same Pinnacle high sensitivity detector within it. Again, ideal for return air grills. Prior to us launching this product, it wasn't uncommon for someone to have to put multitude of either air aspiration piping in, or a handful, if not a dozen, spot detectors on a return air grill in order to provide the type of protection required. Duct smoke detectors in this application are a much more cost-effective solution to, again, meet that return air grill requirement. And then finally, another newer product that we offer is our advanced multi-criteria detector, which is using 4 different elements to, again, make that good decision, similar to FAAST, to make better decisions of whether or not we have a fire or just a nuisance-based condition. So in summary here, some of the takeaways. Mission-critical space definitely offers a sizable opportunity, both with aspiration products and other products. Recognize that mission-critical mindset is different. It's not that just, hey, I just want something to alarm and evacuate, but more that I want to be able to use some elements of the fire system to help manage the building and the building system. Getting that IT personnel involved at an early stage, because again, as these systems become more integrated, that IT personnel seems to understand the value of that in a much grander scale. Know the applicable standards. Even though we go through NFPA 75 and 76, there's a host of mission-critical facilities out there that don't necessarily meet the need, and local jurisdictions approve that without having to meet all these standards. And then, finally, FAAST just offers a significant differentiators and value, especially for these mission-critical facilities. And hopefully I pointed out a few of those features and differentiators with FAAST that can help you meet these codes that can be far more stringent than a standard application. And then finally, just don't underestimate the value of being able to pull all these products from one standard or from one manufacturer, such as System Sensor. The whole concept of aspiration and all the other devices that we offer. Again, what we try to really stress is using the right technology for the right application. And that application, the right technology might be vastly different across one standard facility. You could have a host of different technologies that are used within one facility. So with that, I'll turn it back over to David, and it looks like we have some time for some additional questions.
Yeah, we sure do, Andy, and we have half a dozen or so queued up here. So if you do have a question for Andy at this time, go ahead and use your chat box and type it in. Andy, there's a question here. Oops, I just lost it. Just rolled down the screen here. Question here. One of our end users that has dialed in is having issue with his current aspiration system, and he's quick to note that it's not FAAST, but current aspiration system is going into alarm because of vehicle exhaust, and it's showing it as a valid fire condition.
Okay.
he's got a computer room that draws air from where forklifts and diesel engines are used. Sounds like an unfortunate situation, but he's wondering how FAAST would address such a condition.
Well, that's a great question. One of the things that I'd like to point out is in both System Sensor issues a publication called Life Safety, and in the forthcoming issue that I believe is David could give me exact timing on that. I believe it's launching in the next week or two.
Yes, end of the month. Yep.
Yep, end of the month. We actually have a case study on the Science Museum of Minnesota, which is using FAAST actually in a chemical and vehicle storage facility. It's basically a structure within the parking garage, enclosed structure within the parking garage, in which they do forklift maintenance, vehicle maintenance. There is diesel equipment running, other type of similar equipment running in that facility, and that FAAST unit is installed to monitor and protect that particular entity. And you know, with months under its belt, it's performing extremely well with no false alarms to date.
Okay, very
so
good.
I definitely think FAAST has a possibility of being a great solution for that application.
Okay, good. Andy, the next question is the attendee is noting that FAAST can be used, it can be installed with upper and lower pipe entries. And his question is, can they be used at the same time, and is that okay with code? So for instance, if he wants to go underfloor and a ceiling application via the same device.
Yeah, the big thing you have to watch out for in those kind of applications is historically, and more times than not, the pressure differential between the either space and the ceiling or the space and the floor is going to be different. And if those pressures are different between the two, then you would have to use independent devices, one to monitor the above ceiling or below ceiling, and then one to monitor below floor. However, if there's an application where that pressure differential isn't there and they are at the same pressure level, there's absolutely no reason why you couldn't bring piping in from the bottom of the unit or the top of the unit. Again, you would have to check with make sure you get approval from local jurisdictions, but there's nothing in the specific code that says that you couldn't do so. Again, I just implore you to really verify that pressure differential, because that can cause a problem.
Okay, all right. The next question is, how is the math determined on how far the farthest port can be in an aspiration system?
Okay. There's two different ways that this is kind of done. The agencies, the UL and many other agencies, basically test the system with one single pipe length. So it's one single pipe length. There might be multiple holes, but they're just worried about and just checking for an agency listing that last pipe. So I know even on our data sheet we call out the length of that. Excuse me, the length of that capability. And however, within our PipeIQ software, what it does is it actually looks at not only that last point, but it looks at all the points. And there's a variety of math equations involved in that to verify both that you get a relatively equal flow coming in from each one of the sampling points, as well as that you don't have any drastic pressure differentials at those different sampling points, such that one hole would be maybe providing all the sample and other holes would not be pulling it in. And our PipeIQ software does that, so as long as you're using PipeIQ, it will determine that. I'm afraid there's not a real simple and easy answer to that. Hopefully that gets, that'll be posted online, and maybe we can provide a more detailed answer to that individual who asked it.
Okay. All right. We do have that contact information. Andy, next question has to do with duct detection, using aspiration for duct detection. Is there a procedure for determining how to install FAAST in ductwork to replace the duct detector? And he's noting here he has limited space for mounting duct detectors.
Okay. There's several applications that we already have out in the field and running are in HVAC or in duct applications. We also have a white paper on the on our website, which again we'll forward out to this individual. But If you go into the technical support section of our system sensor website, we do have this technical paper which basically gives you a kind of line-by-line how-to of how to set up a aspiration system within a duct system. And I recognize that some applications, even though a duct smoke detector works extremely well, some applications don't allow for that space on the exterior of the duct to mount it. Aspiration systems are great for that because you can mount the actual device further away from the duct and then just run the pipe into an area where you can access and tap into the ductwork. So definitely a great application and far more widely used and accepted than I had thought previously. So.
Okay. All right. He's wondering if FAAST, the next question is wondering if FAAST has a 4 to 20 milliamp output in addition to contact closure.
Not at this time. It does not have a 4 to 20 output. At this point, the conventional product has the contact, dry contact closure only for the 8 different conditions. So that's the 5 alarm conditions. Minor fault, major fault, and isolate conditions all have a dedicated dry contact relay associated with it. So today that's the way you'd have to tap in and associate with it to communicate back. However, we are looking at other communication, both protocols as well as means in order to communicate with, again, tying it better into the building management system rather than just worrying about tying it back to a fire system.
Okay. A couple of questions here that are related. I think I'll just go ahead and answer them, Andy, if you don't mind. A couple of questions relating to, can I get a copy of the webinar? Will we send out a certificate of attendance? And does this have any CEU credits for attending? First, a copy of the webinar. We will make it available on systemsensor.com/webinars. We should have that up by the end of the week. We will offer a certificate of attendance, or we will issue a certificate of attendance to anyone who physically attended the webinar, and fortunately our webinar software tool allows us to see who attended today. And then also, do we have CEU credits for this webinar? No, but we do know that some states allow the hours that you have in training to count towards local state training requirements. So we will offer that certificate that you can turn in and show an hour participation here. Andy, we probably have time for one more. We've got about 30 seconds to the top of the hour here. Let me pick out one of these here. Let's see, reference listings for FAAST at the moment. So UL, EN, CSA, et cetera. What do we have listed and what's in the pipeline to be listed? Andy, are you still there?
I'm sorry, yep. Here, I brought up a slide that actually shows all the agency listings.
Okay. So
definitely anything domestic here within the states, North America, UL, FM, California State, Maryland State, also ULC if any guests are with us from Canada. We have additional agencies in process, including European listings, Australia listings, China, Korea, and Singapore. Going back to the U.S. listings, I will also note to the question that was asked earlier that the FAAST device also has the UL DI listing for in-duct listing from 300 to 4,000 feet per minute air velocity, as well as an in-duct application listing for FM. So definitely gives you some options, and if there's some other standards that someone's looking for within the Americas, please feel free to send us a note or an email, just because we think we got it pretty covered here from the America standpoint.